Heat stress is more than just a bad day for your birds. It is a direct threat to the financial health of your entire operation. When temperatures climb, poultry struggle to maintain their normal body functions. This struggle comes at a significant cost. You will see reduced feed intake, slower growth rates in broilers, a noticeable drop in egg production for layers. The eggs that are produced are often smaller, the shells are thinner, that makes them less marketable. This silent thief works subtly at first. Its cumulative impact can devastate your bottom line over a hot season. The economic consequences extend far beyond simple production metrics. Heat-stressed birds have weakened immune systems. They become more susceptible to disease. That leads to increased medication costs and higher mortality rates across your flock. Feed conversion worsens. Investing in heat stress management is not an expense. It's an investment in profitability and sustainability. To effectively combat heat stress, we must first understand how it works on a physiological level. Birds, unlike mammals, do not have sweat glands. Their primary method for cooling down is through panting, or more accurately, gular fluttering. This rapid breathing process increases evaporative cooling from the respiratory tract. However, this mechanism is energy-intensive and has serious side effects. As a bird pants, it expels large amounts of carbon dioxide, which leads to a change in blood chemistry. This condition, known as respiratory alkalosis, disrupts the bird's acid-base balance, negatively affecting calcium metabolism for eggshell formation. The ideal body temperature for an adult chicken is around 105 to 107 degrees Fahrenheit, or about 40.6 to 41.7 degrees Celsius. They are most comfortable in an ambient temperature range of 65 to 75 degrees Fahrenheit, which is 18 to 24 degrees Celsius. When the environmental temperature rises above this zone, the bird must actively work to dissipate heat. It does this first by radiating heat away from its body, often by holding its wings away from its sides, and through vasodilation. When these passive methods are insufficient, panting begins, marking the transition into a state of active heat stress. Proper ventilation is the single most important tool in your arsenal. The primary goal of ventilation in hot weather is not just to bring in fresh air, but to create sufficient air velocity to produce a wind chill effect that cools the birds directly. In commercial poultry houses, this is achieved through tunnel ventilation. This system involves pulling air through the entire length of the house using large exhaust fans at one end, while drawing it in through evaporative cooling pads at the other. The key is to achieve an airspeed of at least 500 feet per minute or 2.5 meters per second directly over the birds to effectively strip heat away from their bodies. For this system to work, the poultry house must be completely sealed. Any leaks from curtains, doors, cracks in the walls will short-circuit the airflow, drawing in hot, humid air from outside instead of cool air through the pads. Regularly perform a static pressure test to check for air leaks and seal them promptly. Ensure your fans are well maintained, with clean shutters and properly tensioned belts, to guarantee they are operating at their full capacity. Small-scale and free-range operations can also apply these principles, maximize natural airflow, orient coops, install screened openings, and use clip-on fans. Water is the lifeblood of a bird's cooling system, and maintaining hydration is non-negotiable during hot weather. A bird's water consumption can double or even triple as temperatures rise above 85 degrees Fahrenheit or 29 degrees Celsius. If water access is limited, if the water is too warm, this quickly leads to dehydration, which thickens the blood, puts a strain on the heart, and severely hampers the bird's ability to cope with the heat. Ensuring an adequate supply of cool, clean water is paramount. The ideal water temperature is between 50 and 55 degrees Fahrenheit or 10 to 12 degrees Celsius. Water that is too warm, above 80 degrees Fahrenheit, will be rejected by the birds. To keep water cool, you must flush your water lines frequently. A regular flushing schedule, especially during the hottest part of the day, removes warm, stagnant water in the pipes and replaces it with cooler water from your source. For smaller operations, this can be done manually. For larger farms, automated flushing systems are a wise investment. Ensure you have enough drinkers for your flock size and that they are positioned at the correct height for easy access. Nipple drinkers are efficient, but you must check them daily and ensure they are not clogged and delivering adequate flow. Clean bell drinkers daily to prevent biofilm and bacterial buildup, which can discourage drinking. During extreme heat, consider supplementing water with electrolytes and vitamin C as a support, not a replacement for cool water and ventilation. So, as temperatures rise, a bird's natural response is actually to eat less. This is a self-preservation mechanism to reduce the metabolic heat produced during digestion. Therefore, the goal of a hot weather feeding strategy isn't to force the birds to eat more, but instead, to provide a more nutrient-dense diet so they can get the nutrition they need from the smaller amount of feed they consume. One of the most effective strategies is to increase the energy density of the feed by adding fat. Fat has a lower heat increment of feeding compared to proteins and carbohydrates, meaning its digestion generates less metabolic heat. By replacing some carbohydrates with a high-quality fat source like vegetable oil or poultry fat, you can provide more calories with less heat production. Protein and amino acid levels must also be carefully managed. While protein is essential, its digestion generates a significant amount of heat. So, it is advisable to reduce the overall crude protein level slightly, but supplement with key synthetic amino acids, lysine, methionine, and threonine. This approach, known as the ideal protein concept, allows you to meet the bird's exact amino acid requirements for growth and egg production, without the metabolic cost of processing excess nitrogen from whole proteins, thereby reducing the overall heat load on the bird. Timing your feeding schedule can also make a substantial difference. By adjusting your feeding system to provide fresh feed during the coolest parts of the day, early morning and late evening, you encourage birds to eat when their bodies are under the least thermal stress. Split feeding or removing feed midday reduces metabolic heat during the hottest hours, for example 1 p.m. to 4 p.m., a common commercial practice. The physical structure of your poultry house plays a fundamental role in passive heat management. A well-designed house can honestly make a big difference. It can significantly reduce the cooling load on your mechanical systems. One of the most impactful and cost-effective modifications is painting the roof white or using a reflective roofing material. A dark roof absorbs a tremendous amount of solar radiation, transferring that heat directly into the house. A white or shiny surface can reflect up to 85% of the sun's rays, dramatically lowering roof temperature and reducing heat radiating down onto your flock. Proper insulation is another critical component, especially for the roof and the ceiling. In hot climates, install a ceiling with a high R value. For small-scale and free-range farmers, providing ample shade is a simple but powerful strategy. If trees aren't an option, build shade structures with shade cloth. Make them tall enough to allow good airflow underneath. Building orientation matters for new construction. Orient a rectangular house east-west to minimize exposure to intense morning and afternoon sun. Add adequate roof overhang to shade sidewalls at midday. These passive design elements reduce heat entering the building, lessen the burden on active cooling systems, and create a more resilient, energy-efficient operation. These modifications pay back through lower running costs and healthier birds. Consider sustainable upgrades like solar panels to offset cooling costs. Small passive improvements can transform performance during heat waves. Next, how to spot trouble early so you act before losses occur. Your birds will tell you they are in trouble long before mortality begins, but you have to know what to look for. Being able to recognize the early signs of heat stress is critical for timely intervention. The very first behavioral change you will notice is a reduction in activity and feed consumption. Birds will appear lethargic, preferring to sit quietly rather than move around. They will also spend more time at the drinkers. As the stress increases, you will see them holding their wings away from their bodies. This exposes the less feathered areas under the wings so more body heat can dissipate. As the situation worsens, the most obvious sign begins, panting. Then it progresses to rapid open-mouthed breathing, gular fluttering. Widespread panting across the flock is a red flag that your environmental control measures are failing. Combs and wattles may first be bright red, then start to appear pale and finally bluish, cyanotic. That indicates circulatory failure. Birds may become uncoordinated and stumble or be unable to stand. Some lie down with head and neck extended, signs of extreme heat prostration. At that point, internal temperature has likely exceeded coping ability, and death is imminent without immediate intervention. Beyond visual cues, production data provides crucial early warnings. Monitor egg production, egg size and shell quality daily. Monitor water and feed consumption for spikes or drops. They are early warning signs. Despite the best-laid plans, extreme and unexpected heat waves can overwhelm your standard cooling systems. In these emergency situations, you must act quickly and decisively to prevent catastrophic losses. The first and most important action is to maximize airflow immediately. If you have a tunnel-ventilated house, ensure all inlets are correctly configured to achieve maximum air velocity over the birds. For naturally ventilated houses, open all doors, open windows and curtains to encourage any available breeze. Use supplemental circulating fans to keep air moving in dead spots. When ventilation alone is not enough, you must introduce water for evaporative cooling. If you have a misting or fogging system, run it in short, frequent cycles. The goal is to cool the air through evaporation, not to wet the litter or the birds. If you do not have installed systems, use a backpack sprayer or a hose with a fine mist nozzle to spray a mist into the air above the birds. Another effective emergency tactic is to gently hose down the roof. Evaporation from the roof surface can reduce radiant heat entering the house. Directly cooling prostrate birds can be a last resort. Submerging the bird's head and neck in cool, not ice-cold, water for a few moments can rapidly lower core body temperature. Handle these birds gently to minimize additional stress. For a less invasive approach, wet the birds' heads or legs with a sprayer. Avoid soaking the entire body. Matted wet feathers and poor airflow can make things worse. All non-essential activity in the house should cease to avoid disturbing the birds and causing them to generate more heat. Postpone stressful activities like vaccinations or bird movements until the temperature has dropped. Dimming the lights can calm the flock and reduce activity. These emergency interventions are your lifeline. Have a clear plan of action ready and practiced. Beating heat stress is not about reacting to a crisis, it's about building a resilient system through proactive, year-round management. Success lies in integrating strategies into a comprehensive plan. Start with a well-designed, properly maintained house, minimize solar heat gain, maximize airflow. Keep ventilation and cooling systems in peak condition. Maintenance, cleaning, and testing. Deliver cool, clean water in sufficient volume. Regular line flushing and drinker maintenance are essential. Work with a nutritionist on hot weather diets. Provide dense nutrition without extra metabolic heat. Daily observation and production data tie it all together. Read posture, watch breathing, note activity levels. Make small, timely adjustments to avoid emergencies. Pre-season maintenance prevents failure on the first hot day. After a heat wave, review results. Were fans adequate? Did pads perform? Was the emergency plan effective? Use insights to refine, invest, and adopt continuous improvement. Turn a recurring threat into a manageable challenge and build a more profitable, sustainable operation. Use efficient ventilation, water-saving systems, and renewable energy where possible. When you invest in prevention, you protect both welfare and your bottom line. Recap: seal and ventilate, keep cool water, reformulate feed, provide shade, maintain equipment, monitor data, and practice your emergency plan. Subscribe for more practical farm management guides. Links to checklists and supplier references in the description.